Let's look at an application that involves a rational function. And you'll have some of these that you have to set up yourself as well. But for now, I just want to look at the kind where you're given a function. It's usually not a terribly complicated rational function. And you are asked to either sketch a graph or interpret some of the characteristics of graphs. In which case, I still think it's helpful to sketch the graph or use technology. A lot of people are fairly visual. So if they get a picture, they can figure out what it's telling them, but just looking at the formula, they can't always get the correct information. So this one does ask you to sketch first. So let's go through our local and global behaviors. We have n of p equals 5p plus 400 over p. So for zeros, I want to think about when 5p plus 400 is equal to 0. And that happens if 5p is equal to negative 400, which means p is equal to negative 80. So kind of getting into this already, price p, I don't think I want to look at negative price. So it looks like we're going to get this x-intercept at a point that's not really useful for the overall situation, but it might help us kind of figure out what the graph looks like. So I think it's okay to still write this down just for our work. So negative 800, no, I'm sorry, negative 80, 0. Vertical asymptotes or holes. We would check when the function is undefined, which means the denominator equals 0. And that is a simple one. Since the denominator is just plain old p, it happens if p equals 0. Since there is not also a lone p to cancel out of the top, there is no hole in the graph, so it's just going to be that vertical asymptote. And then our global behavior is, will it be a horizontal or slant asymptote, or is there something weird going on where we've got none of that? Here, the numerator is first degree, it's linear, power of 1. The denominator is also power of 1. So they tie. If I plug in 1,000,000, I have just slightly over 5,000,000 in the top, and I have 1,000,000 in the bottom. And if I plug in 1,000,000,000,000, I have roughly 5,000,000,000,000 over 1,000,000,000,000. So again, this only works when we're talking about plugging in massive numbers, but that's exactly what we're talking about with global behavior. We're trying to say as x goes to positive infinity, what happens to y, and as x goes to negative infinity, what happens to y. So we're going to have a horizontal asymptote, and it's at, I guess, n, or y would be fine with me. N equals 5. So when I go to graph this, I have a vertical asymptote at p equals 0, and a horizontal asymptote at n equals 5. So this isn't tons of info to go with, but that's where I think, even though that negative 80, 0 doesn't fall within our reasonable domain, let me just do another smaller sketch here. I think it is interesting information. It means somewhere way out here we're crossing this horizontal axis. So we needed to start from near our horizontal asymptote and then cross. And since we're not allowed to cross the x-axis again, we'll be forced to go to negative infinity. Everything is multiplicity 1 here, so p in the denominator will change signs, which means we need to switch from negative y values to positive y values. And then there's no other local behavior, so it's just going to tend back down towards that horizontal asymptote. And this one really is just a transformation of a 1 over x or 1 over p. So we are seeing that shape show up here with none of the extra weird stuff that we've seen in some of the more complicated functions. So what this is telling me is very rough here, but we should be doing something like this. And then to get a little more accuracy for the purposes of this problem, I think it'd be great to maybe plug in 1 or 2 values just to get the idea. So for example, we could plug in p equals 10, and this would just be scratch work. So we would get 50 plus 400 over 10, which is 450 over 10, or 45. So we know we go through, so we'll say 10 is not very far out here. This is still not quite to scale, but gives us the right idea. This would be way up at 1045. And you can grab some more points if you want, but it's going to work its way down toward n equals 5 eventually. So sort of rough, but this should give us the idea. So this is Okay. From here, you'll be asked to sometimes plug in a number and explain what it means. So we could use that 1045 I just found. This is the p-axis, this is the n-axis. So that means at a price of $10 per gallon, there are still 45 people that would buy milk. You may also be asked, when will the number of gallons sold equal 100, in which case you'd have a little algebra problem there, and I'm not going to run through that right here, but let me know if you run into any trouble. We did work through some of that in your functions and algebra sections. What I want to focus on here is the new piece. I want to talk about the meaning of the horizontal and vertical asymptotes, and I want to remind you that even though the equations for those only involve one variable, it is actually telling you about both variables. So we know that near p equals 0, it's really kind of a limit statement. It's really as p gets close to 0 and will head to infinity. And I'm going to give you a little extra calculus notation. You don't have to use it, but you'll get it shortly if you're headed to calculus. We can even say only looking at the right-hand side, which means just put a little plus, almost like an exponent. We're not interested in the left-hand side of that asymptote because it falls outside of our reasonable domain. We don't want to look at negative prices. And this n equals 5 really means as p gets very, very big, n is going to get really close to 5. And I think it will matter a little bit for our thinking that we're approaching 5 from above. So the number of gallons is dropping to 5. Okay, so let's look at this one first. I would say here, what that's telling me is that as the price gets really close to 0, so as you approach giving milk away for free, the number of gallons that you're going to be able to quote unquote sell is skyrocketing. It's headed to positive infinity. And while we maybe can't really sell an infinite number of gallons of milk from a store, I still think this is getting across some good meaning. I think that makes sense to say that according to my model, if I was able to keep shrinking this price down, demand would go crazy, right? It would just get bigger and bigger and bigger the cheaper I made it. Again, realistically, there's probably some cap on that. Maximum number of people in the area and how many gallons of milk they'd want anyways. I don't think somebody probably wants 1,000 gallons of milk because you wouldn't be able to use it, but I think it gives the right idea. For the horizontal asymptote, that's saying as p gets really, really big and drops to 5. So this is saying as you raise the price more and more and more, the number of gallons demanded drops off to 5, but then it kind of sticks there, right? It's not dropping below 5. So again, you can't really charge infinitely much for milk, but I still think we're getting some good meaning out of this. It's saying even as milk gets very, very expensive, there's apparently 5 people who would still want 1 gallon of milk, or 1 person who would still want 5 gallons of milk. Whatever it is, it's saying even as the price gets outrageous, maybe you've got 5 really wealthy people that are still going to go for it and say, I want my milk, I'll pay a lot for it. So these are the extremes, right? And they might get a little too extreme, but I still think they're giving us some information about this situation. Make sure you're explaining what's happening to both variables. It's not just P or N that's involved in a horizontal or vertical asymptote.